Hi everyone. Now we're gonna talk about a recursion. So, what's a recursion? Recursion is a simple, actually very simple to understand. It's basically we call a recursion when a function calls itself, to to solve any problem or like to achieve some goal. So, for example, very well-known example is a Fibonacci numbers. Um, you might have heard Fibonacci numbers. It's basically numbers which are given in this form. So let's say we want to find nth Fibonacci number. Our nth Fibonacci number will be equal to fn minus 1 and plus fn minus 2. If we write those Fibonacci numbers in order, we will get this number. If we assume the first two numbers are 1, 2, so the last two numbers are 1, 2, and summing them we will get number 3, and 2 plus 3 is 5, and summing 3 plus 5 would be 8, and 5 plus 8 will be 13. So these are the Fibonacci number, and it goes till infinity. So what this problem requires us to do is to find nth Fibonacci number, which is in this case our first Fibonacci number will be 1, and the second will be also 1, and the third is 2, and fourth 3, fifth 5, 6, 8, and the 7 is 9, 13, and so on. So how to achieve this goal? There are actually a lot of ways to solve this problem, but right now, for the sake of example, we will use a recursion. So let's say as user inputs a number n, and we want to output the nth Fibonacci number by calling the function fn. And how we gonna implement this function is by simply calling the same function again 2 times. So if let's say our n is 5, we'll call n here will be 5, and n will be here 5, and we will call the same function with fn minus 1, and it will become 4. But a very important thing is that it will not use the same parameters again. It will assume that the new calling function would be call it with the new parameters, like assume that it is a newly created function which has nothing to do with the function which is which was calling. So let's assume there is a caller function and callee function. Caller function is f, and callee function is also f, but those two functions don't have anything in common. Actually, they are totally different functions. We will assume that. But another issue in this problem is that if you right now try to run this program, it will actually not stop, and it will not stop, and it will crash at some point. Why is that? Because it will call the same function itself again and again until forever. We don't identify here where we should stop, or like how we should stop. So another important thing in recursions are a way to stop, or stop statements, stop conditions. And for the Fibonacci number, it will be when n is 1, where we can just return 1 without computing, and when n is 2, we can return 1, 2 again. So let's try to rerun again and see what it's gonna give us now. Oops, I accidentally opened let me try to rerun this again. I accidentally opened the debugger in order to run it, so let me run it again and see. Yeah, so fifth, it says fifth Fibonacci number is 5. So far it's good. Let's try to run again and give some other number. Let's say 6. It says 8. Yeah, good. Saying it's computing all right. And if we do 7, it's giving us 13. Yeah, it's perfect. So so we solved this problem, but we need to understand very deep concept about recursions. In order to understand this more a bit deeper, I will change a statement for this problem a little bit. So let's say in order to give to output the nth Fibonacci number, we will output the Fibonacci number from the 1 to n. So the simple maybe for some answer would be just to save the Fibonacci number here, output it, and return the same Fibonacci number. And it makes sense from the like we're going to the pre-last Fibonacci number and then the pre-last, and we're gonna just output. Let's see how it's going to give us. So if you write 7, it's a bit strange output actually. If you see, like we are outputting the same values multiple times. So what's going wrong? What's going on at all here? It's actually very simple too. So we actually can guess that recursions are a bit complicated in terms of understanding how it's going to call. So as I said, each caller is independent of each callee. So if we say a caller has two callees, in this case, for example, the caller fn is trying to call fn minus 1 and fn minus 2. Then for fn minus 2 minus 1, it's gonna call fn minus 2 and fn minus 3. And this one, this fn minus 2 is independently of this fn minus call, is gonna call its own callees, which will be fn minus 3 and fn minus 4. And again, this fn minus 2 is gonna call the same functions again and again. So it's gonna go very it's gonna call a lot of functions many times. So if you, for example, try to run the program again and write 100, it might take a while in order to finish computing these numbers, like as you can see, because like it's calling like 100 fn f100 calls fn 99, fn 98, fn 99 calls another fn 97 and fn 96, and so on. So it's becoming a huge tree if you see the whole structure of recursion as a tree, and the top the root of the tree as a n fn, and other subtrees as an fn minus 1, fn minus 2. It's gonna become like, it's gonna grow it's gonna grow like exponentially. So in let's try another example. Let's try, for example, 200. Yeah, like as you can see, it's already eating, like wasting, consuming a lot of CPU, a lot of power, and that's why it's my machine is almost like going to break. So yeah, so yeah, basically that's it. I hope you guys get the concept. The most important thing in recursion is getting the concept, and I hope you got the concept, and I hope it will be useful.